before the month. So, okay. So simple stuff. We have function f of x broken into two pieces. One piece is the line y equals x minus 2, and one is the line y equals x plus 3. You know, the first one would just be a line of slope 1 shifted, with the y-intercept of -1. So if you drew that all by itself, it would, or y-intercept of -2, it would look like this. If you drew the whole, don't draw this, but, it'd just be something like that. That would be the line y equals x minus 2. And the line y equals x plus 3 would be, just shift up at 3, right? But we only want part of the first one and part of the second one. So when we only want the first one up to -1. So we take off everything after -1. So we take off everything after -1. We get that. And then for the other one, we take off everything before -1. So we get that. They can't both be defined there. One of them gets a closed circle, one gets an open circle. So the one that just has the less than -1 gets an open circle there, and the other one gets a closed circle here. Does that seem familiar to you?
Yes.
A few people, yes. You don't have to graph both functions completely to know where to put them. If you just plug in, so like for the first one, if I just plugged in -1 here, so -1 minus 2, I'd get -3. And look, that tells me that's the -1, -3 down there. So it tells you, oh, that piece starts there and it has a slope of 1. And then if you plug in -1 to the other part, -1 plus 3, you get 2. And then that corresponds to that point right there. And then you form the rest of the line with slope 1 going up. That's the whole idea. Okay, so we have that. Now let's look at 3 pieces. Okay, we got -1x if x is less than or equal to -4, x if it's between -4 and 3, and then 5 if it's greater than 3. So, start me off. First thing I can do, what do you think, Ian? First thing I could do here? Not sure? Okay.
Like 3 minus -4.
3 minus -4? Oh, yeah. Yeah. So let's look at that. So for the first one, I was like, I plugged it into each piece. I plugged that boundary point where the function changes into each piece of the piecewise function. So I will take -3 and 4, or sorry, -4 and 3 and plug it into different parts. So like for example, if I take -4 and plug it into -x, I get -1 times -4 equals 4. So then I have one point at the, I have one point at -1 comma 4. That piece is the line y equals -x when x is less than or equal to, oops, I graphed that wrong. -4 comma 4. When x is less than or equal to -4, it's equal to the line y equals -1x. So the line y equals -x is just a line of slope -1. So you could just start at that point and draw a line of slope -1 going back. let me know if something doesn't click so I can address it right away. Right, because this piece, all this piece is telling us is the domain on which we graph y equals negative x. That's what it's telling us. So for the domain x is less than or equal to negative 4, we graph the line y equals negative x. Then the other one, y equals x, if you're between negative 4 and 3. So I can plug in for y equals x, I plug in negative 4. So that gives me the point negative 4 comma negative 4. If I plug in 3, I get 3 comma 3. So on the left side I have negative 4 comma negative 4 with an open circle because x is only greater than negative 4 there. And then I have a closed circle at 3, 3. And I can connect that line together like this. It's just a slope 1 line. Parker, do you know what the last piece looks like?
It's just a straight line going across at y equals 5.
Yep, exactly. A straight line at y equals 5, starting when x equals 3 with an open circle. Just a constant function. Okay. We continue. Okay, so you can also write the function when you see the graph. So this graph has 2 pieces. Let's see, Andrea, what's the left piece of this graph?
It would be y equals 5
Mm-hmm.
when x is less than or equal to 0.
Perfect. Thanks. Okay, so it's just 5 when x is less than or equal to 0. And then, Ethan, can you tell what the right piece is?
2x plus 2 if x is greater than 0.
Yep. The 2x coming from the slope of 2. Y-intercept 2. So y equals mx plus b, 2x plus 2. Okay, you try those 2, and then we can check in just a minute. you want to check your answers to those, they are up here. And let me know if there's any question on it, or if you can't read what I wrote. Yes, ma'am.
For the first, like, graph line.
Yes.
Or I guess, point, but why would it go up if it's got like a slope of negative 2x?
Well, it's going up to the left, right?
Oh.
So positive, yeah. Okay, good. Anything else? Okay, so this is a fairly short homework assignment for you on piecewise functions. Shouldn't take you that long, I don't think. We're looking at having our test next Thursday, so right before Easter break. And the plan for next week will be we're going to do a little bit more on some more advanced piecewise functions on Monday, and then we'll review Tuesday. We'll have Wednesday to keep reviewing, and we'll have a test on Thursday. That's the plan. I'm going to post the first part of the review. Since this is a pretty short homework assignment, I think it would be a good idea for you to go ahead and get the first part of the review done. So that way, come Tuesday, you're ready to just hit, really dig in, and that'll prepare you pretty well for Thursday. So, have a great weekend.